All right, folks. I see we have 12. I'll start at 2:05. All right. Okay, 2:07. Um, let's talk real quick and then we will begin. Now, yeah, if I don't see at least 35 people show up today, I'm not posting this recording. I'm gonna tell you from now. Because I don't understand why it's 2:07 and I'm seeing less than 20 people here. So you can let them know. But I don't say at least 30 people. I'm not posting this. Now, as you know, next week is the in course. And as you should also know, you are getting digestive system skin, endocrine system. I've decided to leave off the balance of the urinary system to make things a little easier. But you're still getting those and electrolytes, sorry, don't forget electrolytes. And electrolytes as well. Okay. So please be aware. Now,
Sorry, can you repeat the topics, please? And the ones you still leave off?
digestive system, skin, electrolytes, endocrine system.
Okay, sir.
Okay. All right. Also, I mentioned it last week, but I'm going to mention it again, that you also need to review the information in the PowerPoints I send you for the lab. All right. They all contain pertinent information. I wouldn't have sent them to you if they weren't relevant to you, right? Especially, for example, well, let me show you what I'm talking about. Especially when it comes to things like the part I said that you need to review for tests, for quizzes. All of this information is still relevant because please remember, when you're doing your in-course test, the structure and function, which means everything you've done in the lab is also going to be a relevant part of it, right? So please ensure you go through the PowerPoints I've sent, yes, but you also go through your lab information because it is a part of the course. It is not separate from the course, okay? For example, we didn't spend a lot of time talking about digestive enzymes. We've not mentioned some hormones. In your lab information here, you have a table which lists some of the major hormones as well as the major enzymes. All right. Please ensure you go through this. Please ensure that you go through the information in your lab manuals with regards to the worksheets. Information from there can also show up, right? So when I say you're doing an in-course test and it's on everything that you would have done since you started the digestive system, I mean everything. Okay. Any questions so far? All right. So that said, let's move on to, I think the next thing we're supposed to be doing is skin, if I remember correctly. I should mention that I've posted tutorials. What is the question? Let me see. As I said at the beginning, I've decided to leave out the urinary because you know why make things more complicated than they need to be, right? So I've left out the urinary. So it's all right, but the rest of the stuff it will be included, right? So we're supposed to be doing skin today and hormones as well. Now, have you all been told when the semester is going to end? Anybody? Do you know when the semester ends?
Sir, I think they said all classes close April 15.
Yes, right, April the 15th. Now, that makes things a little tricky because I wanted to have a class on the 16th to complete anything that is outstanding. I'm not sure if we'll be able to finish the reproductive system in its entirety by then. I might just have to touch the major points. Um, but aside from that, I think we should be fine otherwise. Right? Anywho,
I'm sorry, good afternoon. Just to
right.
confirm, for the lab manual, we should write everything in pen or we can
Everything
write
in
from.
pen except on the diagrams. You don't need to do pen for diagrams.
Okay, sir.
Mm-hmm. Okay, let's do skin. It won't take long. It's only about 46 slides. A lot of the stuff you already know, right? So for example, here is the basics of skin. Listen, if I said to you all at the beginning that the things need to be done in pen, except for the diagrams. If you want to submit anything in pencil and the reviewer decides that you need to lose marks, it's entirely up to you. Right? There's not much I can do about it. Y'all keep forgetting I am not the only one reviewing these things. Right? If it is said, pen to answer questions, which is a common thing, and pencil for diagrams and tables, which is a common thing, I don't know what to tell you. Right? So you have to make up your own mind. Basic information. The integumentary system is not just the skin. Even though I've been saying skin all along. The integumentary system includes your hair and your fingernails as well. And we'll be looking at all of those in not very great detail, right? But in some detail. Now, what are some of the things that your skin can be said to do for you? Your skin has an impact or is impacted by your nutrition. For example, everybody knows that vitamin E is required to keep your skin healthy. Your hygiene. Weirdly enough, when I say hygiene, I don't just mean bathing. I mean even the type of soap you use. Do you know you can bathe too often if you use so much soap? Every time you bathe with soap, the soap dissolves the oils on your skin, and the oil acts as a protective barrier on your skin, and it contains antibacterial substances. If you bathe too frequently with soap, you can actually increase the risk of getting infections, which sounds absolutely crazy, right? And also because it dries out your skin, it means your skin is more likely to crack, and also which will let in bacteria, right? So you can bathe too often with soap. If you're bathing without soap, then hey, that's fine, right? So if you want to bathe with soap in the morning and then bathe 2 other times during the day without soap, perfectly fine. And then the last time with soap before you go to bed. I'm not saying you mustn't shower. All right, I'm not saying you must walk out the house with a nasty self. What I'm saying to you is that you can still wash off and then go. You don't always have to use soap, right? Because the soap can dry out your skin. That is different from saying, me not have to bathe. Okay. All right. Now, circulation. Obviously, your skin requires a fair amount of blood. So anything that limits blood supply to your skin will affect your skin, right? And as you get older, your skin gets thinner and drier, which of course, and it starts to lose some of its structure, which is what causes it to fold up. And you then get wrinkles. It starts to sag first, then the sag becomes a fold, and then the skin itself starts to thin out, and then it dries, and then that's how you get old people's skin, right? And your immune system also can attack your skin, right? Not just that, your immune system is supposed to protect your skin. So depending on how good your immune system is, you might find yourself getting lots of skin infections. Genetics obviously impacts your skin as well, right? Because think about albinism. That's genetic, right? Now, and the sunlight one. Even as we're saying, oh, we live in Jamaica, we're in a tropical place, sun is shining every day, which is not quite true, but sunshine most of the time. Why do I need extra sunlight? Because most of you spend your days indoors. And dark skin absorbs more solar radiation and it's less light through, which means you actually need to be out more. We'll talk about it later. Psychological state, excited, depressed, whatever, people blush and these kind of things. So that's obvious. Also, microbes on your skin. I said to you that your skin acts also to control bacteria, like the skin, the oil, and these kind of things. But there are microbes that can live on people's skin that you might not be able to control that will actually give you a bad odor. Okay. And of course, pollution. Depending on where you go swimming, for example, you might be exposing your skin to all kinds of pollutants. For example, I know people who swim in Kingston Harbor. I'm sure you all know Kingston Harbor. It's the 7th largest natural harbor in the world, and it's also extremely polluted. So it should come as no surprise to you when I say to you, you've never heard of Kingston Harbor before. Somehow I doubt that. It is, as I said, the 7th largest harbor in the world. Natural harbor, I should say. Right? Now, if you've ever been to Kingston Harbor, one of the first things that will hit you when you get to near the water is that there's a weird smell in the air. That is because the Kingston Harbor is where the major gully networks in a Kingston dumps its waste, and there are also sewage treatment plants around the harbor that are dumping waste into the harbor as well, and ships that come to the harbor dump their bilge in the harbor as well. So the harbor is one big dilute cesspool, right? People fish in that water, people swim in that water. Same for Harmony Park. I'm willing to take your word for it. All right? Anywhere you have a lot of trade going on, you're looking at basically dilute, at least you hope it's dilute sewage, right? So if you see a whole heap of ship parked there for any length of time, almost certainly they're dumping their bilge where they are, right? And if you walk up to the place and you smell like a slightly rotten egg smell, you know that it's nasty. And if you see gullies emptying in the area, you know it's nasty. And these kind of things can actually lead to a lot of skin infections and eye infections as well. All right? And somebody mentioned even in Mobile, when rain falls and all the nasty muckiness gets washed out of the town, where is it going? It's going to the sea right down the road. Well, the term safe is an interesting one. Is it safe to swim in it? If you fall in the yurt, that you won't die immediately for sure. You know? And once you survive at least a couple of weeks after you've taken a dip, you're no longer the government's problem. So, I mean, technically it's safe. But yeah, you can easily get skin infections. So people who do a lot of swimming in infected water will tend to get lots of skin infections, lots of ear infections, eye infections, things like this, right? Because they're bacteria living in the water. Make it worse, you're one of these people swimming their mouth open. You know how that goes. You ever see people swimming and have their mouth open as they swim? I don't understand how people do that. So you're swallowing the sewage. Good for you, right? Anyway, now drugs. Let me give you an example of what I'm talking about. You all have heard of crystal meth, right? Meth? Can I assume everybody's heard of meth? Methamphetamines, yes? Now, that stuff is in Jamaica. And one of the things that you'll find on in people who take it a lot is it can actually change the way their skin looks. All right, let me give you it ages the skin, causes spotting on the skin. I'm going to give you an example of what I'm talking about, right? Because it's one of these things where I won't say a lot of people are using meth in Jamaica, but it is actually a significant problem in Jamaica, right? So you should be seeing this lovely lady here. Lovely might be a bit of an overstatement. This is, I think it's over a period of what? 3 years, I think it is. So this is what happened to her skin over a period of 3 years. All right? So yeah, there are drugs that can dramatically cause your skin to get damaged by impacting the flow of blood to the skin. All right. So yeah, meth is probably the most obvious one when it comes to skin damage, but there are others as well, right? But meth, as I said, is the most obvious one. Now that we've gone through all of that, let's talk about the basic layers of the skin and then talk about what the skin does for us, okay? You're looking at 3 basic layers. Your epidermis, which is your outermost layer, your dermis, which is your middle layer, and your hypodermis. Hypodermis is a little funny one because some people say, hey, it's not really a layer of the skin, but we're going to accept that it is a layer of the skin, okay? So epidermis, dermis, and hypodermis, which is the controversial one. Now, the epidermis is going to be the layer of the skin that is most involved in protection, because that's one of the things that epiderms do, right? Y'all know from AMP1. So you know, for example, the upper layers of the epidermis here are made up of keratinized, stratified squamous epithelium, right? Let's give you a moment now for your brain to dig up that previous information and say, oh yes, I know what that means. Now, the dermis, which is mostly made of connective tissue, all right, is more of a metabolically, is very metabolically functional. There's lots of things being produced in the dermis, right? This is also where you'll find the major blood vessels to the skin and larger glands like sweat glands, right? And your oil secreting glands and all of those sudoriferous glands and those kind of things, right? Then now the hypodermis now is mostly areolar connective tissue and adipose tissue. And you all know adipose tissue is fat, right? It doesn't have any direct impact on the dermal layer or the epidermal layer, really. That's why some people say, oh, it's not really a part of the skin. But it connects the skin to the muscles, which is why it's important, okay? All right. Now, that said, this is your lovely diagram of the skin. Clearly, you need to be able to label this thing, all right? Clearly be able to label this thing. We'll talk about all these components later. Now, that said, what are the basic functions of your skin? 1, your skin is responsible for regulating your body temperature. How does it do this? You already know from when we're talking about circulation. Remember? When the day is hot, what happens? Blood is diverted via meta-arteriole from deeper down in the skin by the opening of sphincter muscles to let blood move up into the higher layers of the skin, which allows that warmer blood to release heat. So vasodilation, as you rightly say, of your meta-arterioles leading towards the skin, right? So more blood gets to the skin, heat is released, right? Then, of course, added to that, we say, okay, we also have sweating going on. And as you put sweat on your skin, the heat on the skin is absorbed by the sweat. The sweat then evaporates, turns into water vapor, and floats away and takes the heat away with it. So we know how it regulates. If it's too cold, on the other hand, the meta-arterioles divert blood now deeper down into the skin, more into the subcutaneous layer of the skin, which of course is the hypodermis, where it can be insulated and you keep more heat in, right? So you already know that stuff. But when it comes to sensation, your skin has many, many different mechanisms for sensing the environment. For example, you all know, because you can touch it yourself, The hair on your skin is extremely sensitive to touch, right? That's why sometimes you're sleeping and maybe a ant or sitting on minding your own business and an ant gets on your skin and it's walking along the hairs of your skin, you jump up things, you don't pay a touch you, right? Or if you are outside and the breeze is blowing, if the breeze is very light, if you have enough hair, you can feel the breeze tickling the hairs on your skin, even if you can't feel the breeze itself. It's because of how sensitive those hairs are, right? And of course, your skin also can sense changes in temperature. So if one part of your skin is hot and the other part is not hot, you can sense it, right? Think about it when you're sleeping on your back, for example, and the night is hot and you're starting to get overheated, what do? You roll over to the other side to let the heat dissipate from your back, right? So you can sense the difference in temperature. Also, deeper down in the skin, you're going to have other sense organs, right? Pacinian corpuscles, which you did in ANP1, for example. I can sense pressure, right? You have pain receptors in the skin, as you know. Once again, from ANP1, which allow you to sense physical pain, right? When you get cut or scraped or something, right? Now, excretion, how does your skin excrete? Sweat, right? Remember, I've said to you about 10% of the water that we need on a daily basis is produced via metabolic reactions, right? So we're making 10% of our water. So it also means that when you're sweating out some of the water you've made. Let's just say, assume it's 10% of the water you make gets sweated out. Therefore, losing that water is a form of excretion. But not only that, you're also going to have salts in the body that are coming out in the sweat. You're also going to have, in some cases, urea and other ammonia compounds that come out in the sweat. There's a reason why stale sweat doesn't smell the nicest. Because the ammonia compounds get acted on by bacteria, and the bacteria breaks them down to release these bad-smelling compounds, right? So your sweat is an excreta. It's being excreted by your body, right? Immune system function. How does it function in the immune system? Your skin acts as an almost complete barrier. You know, I find it fascinating that Jamaicans are the only ones that I know of that have decided to call a smell a color. Right? If somebody walk up and say, boy, you're green today, man. We know what they mean. They don't mean your clothes green. They don't mean your skin green. It means you smell bad. Have you ever heard anybody that say, boy, that boy, they smell green? I'm not sure why green, but it's a Jamaican thing, right? I've never heard anybody else say it.
Sorry, I never seen a cartoon before, sir. Like when people have older and green names. They might not say it, but like that's the color
No,
they
but they
use.
don't turn green. You like see like green scent come off of them. I agree with that. But I'm saying Jamaican people say you green. That's what I'm saying. You know? But yeah, that's one of the more unique things in our language, you know. We call colors scents. Kind of weird, but still. Anyway. So here is what I mean by the barrier. Bacteria, viruses, no matter what it is, if it falls on your skin, they cannot penetrate your skin to get into your body. So if you're in the hospital one day and somebody with full-blown HIV comes in, coughs up blood, splashes all over your uniform, as long as you don't have an open wound, you cannot get infected. Right? And there's no disease-causing agent that I can think of that can just penetrate your skin like that. Well, I mean, there are a few filarial worms, but that can give you parasitic infections. But we're talking about viruses and bacteria. The skin is pretty much a perfect barrier, right? Things like guinea worm, which you've probably never heard of, is in Africa. You just go walking around in their water, and the guinea worm them swim up to you and burrow through your skin into your body. But thankfully, we don't have them something in Jamaica, right? But when it comes to viruses, bacteria can't get through your skin, no matter what it is, right? So it acts as an immune, as we call it, a non-specific barrier, right? So yes, when somebody sneezes on you, it feels nasty, but you won't get an infection from it. Unless, of course, you touch wherever they sneeze on you and then touch your face. Because your face has many mucous membranes that can allow these things into you, right? And of course, the one everybody remembers when you say function of the skin, vitamin D synthesis. Yes, your skin makes vitamin D. Well, that's actually not true. Your skin doesn't directly make vitamin D. What your skin does is your skin sends a precursor molecule, a provitamin D. I think that one is calciferol, if I remember correctly. I'll correct myself in a minute if I'm wrong. And that now goes to the skin, and then this calciferol is hit by UV radiation, right? And then the UV activates the calciferol, and then that now goes to the liver, and then the liver uses it to synthesize vitamin D, right? So your skin does not make the vitamin D. Your skin provides one of the substrates required to make the vitamin D, right? So keep that in mind. Right? So let me say it again to be clear. Your skin does not make vitamin D. Your skin makes one of the substrates required to make the vitamin D. And most of the vitamin D supplements you see online and you buy, that is what is in them. It is a precursor you're getting. It's not the straight actual vitamin D. Because that stuff is flipping expensive, all right, if you want to buy it straight. All right. So, those are the 6 major functions of the skin, all right? And see, I've gone through the trouble of explaining, giving examples in each case, right? Please don't forget, your in-course test will contain structured questions. So, for example, I got to ask you, list 4 functions of the skin and explain them, right? So, keep that in mind. Now, let's talk about the epidermis. There are cell types in the epidermis that are particularly important to us, okay? There are 4 types. And then they're going to be found in different layers of the skin. Let's see if this makes sense to you. First one is your keratinocyte. Now, thankfully, the name of this cell tells you exactly what's in it. A keratinocyte is going to contain keratin, right? So keratinocytes, their main job is to accumulate keratin, right? And as they accumulate more and more keratin, they become waterproof. They become impossible for viruses and bacteria to get through. These cells eventually make their way to the surface of your skin, and they're your first line of protection, right? So keratinocytes accumulate keratin and become waterproof, right? As well as infection proof, essentially. The problem is, as they become waterproof, water can't go into and out of the cell, therefore the cell itself dies. And you're left with a keratin shell, basically, where the cell used to be. And that is your protection. So that is what we call our skin. Normally when we talk about skin flakes coming off of your skin, that's what is shedding from your body, these keratinocytes. Now, you also have melanocytes.
Sir.
And nicely, again, it tells you what's in it. So melano refers to melanin. I'm assuming at least half of you know what melanin is. right? Go ahead, Tessinic.
Sir, is it like when I say the Hannah strip for keratinized?
All right, hold on a second. Let me turn up my mic. I'm not hearing you. Give me 1 second here. All right, come again now.
So I was asking if it's like when they say Hannah strip like that.
Well, I mean, it doesn't have to be like a big old strip. It can simply be the flakes coming off of your skin. Anytime you're shedding anything, dandruff, whatever it is, it's the keratinocytes coming off, right? So, for example, like people with me who have well, anyway, let's leave that alone. So melanocytes. I'm assuming everybody has heard this term before. You know what it is, right? These cells produce melanin. Melanin, of course, is the major coloring, let's call it coloring agent to our skin. So like we're making dyeing food or something, right? But it is a very important pigment to the skin. It's the most common pigment to the skin. It is the one that is absorbing excess UV radiation from the sun, right? People don't realize, it doesn't really occur to us on a normal basis, that the sun is actually flipping dangerous. All right? The sun is dangerous. How dangerous is the sun? Every animal that walks upon the surface of this earth has some means of protecting itself from the sun rays. Right? Animals like dogs and cats, they have their fur, and their fur will contain melanin and melanin-like compounds that absorb UV radiation. Right? We, of course, have the melanin, which absorbs excess, hopefully, UV radiation. Why is this important? Because UV radiation will give you skin cancer, which will kill you. All right? People always talk about, oh, you know, this earth was made for man, how it suits us. No, the earth don't suit you. You suit the earth. Right? The earth took your ancestors and killed off the ones that they never want until we're what's left. So keep in mind, right? Now, later on we'll talk about the difference in skin color that is dependent on your geographic location, right? Now, Merkel cells. This is a type of touch receptor that we didn't mention earlier. When somebody just puts their hand on you, we're not talking about squeezing, just put the hand on you. This is what the Merkel cells are for. They can sense touch, okay? This is the way the Pacinian corpuscles can sense a deeper touch. They sense pressure. Merkel cells are just sensing regular touch, right? And then these cells here now, Langerhans cells. You might never have heard of these cells, but these are very important to the health of your skin. They're a kind of macrophage. And they roam around the layers of your skin, and they help to control bacteria, etc. Right? As you get older, the number of Langerhans cells you have starts to dramatically diminish. And as this happens, your skin infection chances go through the roof. This is one of the reasons also why older people are much more susceptible to skin infections. Right? And look here, it is easily damaged by UV radiation. As you get older as well, you produce less melanin for sure, but your skin also gets thinner. So your Langerhans cells are more vulnerable to UV damage, right? Now, once again, Black people don't really worry about these things too much because we think we're immune to the sun, but we'll talk about that in a minute. All right, so those are the 4 main types of cells you'll find in your epidermis. I said to you earlier that we also separated epidermis into specific layers that have functions, right? So here are the layers in order, okay? We have the stratum basal. Some people pronounce it basale, whatever. This contains one layer, so it's a simple layer of cuboidal and columnar cells. So this is a mixed layer of cells. And they are constantly dividing, they're constantly replicating, and they contain melanocytes and Merkel cells. So remember, the melanocytes are making the melanin. So your stratum basal is where you're going to get the melanin from, right? And your Merkel cells are there, help you pick up the touch, right? Then sitting above it now, you have a row of 10 rows of cells now called stratum spinosum. And even though the melanocytes are below them, remember the stratum basal is the lowest layer, the stratum spinosal cells are full of melanin. Why is that? Because the melanocytes are passing the melanin they make up to these stratum spinosum cells. So you're probably asking yourself, why do melanocytes make melanin and then give it away? All right. Let me ask you a question. Why is it when rain or fall, open an umbrella? You could just get wet, it won't kill you. But guess what? Just the same way you don't want the water directly on your body, so you have the umbrella, your lower level of cells does not want UV radiation directly hitting them, right? So what do? You put your protective cover above you to protect the lower levels, right? Hence, stratum spinosum full of melanin to protect the underlying tissues, okay? Then now above the stratum spinosum, you have a layer called stratum granulosum. Now, as usual, if you look carefully, the word is going to give you some information about the cell itself. I should have mentioned this before. Spinosum, spin here is spiny, right? When you look at these cells under the microscope, they have like sharp and corners, and they have little spines. Hence, they're called the spinosum. So stratum granulosum, you clearly see the word granule here. I should tell you that they're going to be granular cells, right? All right. Notice 5 rows of flattened cells, right, with dark staining granules. Then you have this layer here, and this layer here is a special layer, stratum lucidum. Why is it special? It is only found on the palms and the soles of the feet. This is the one that is transparent. You know, when you're a child, I don't know if you did this, but when children are bored, when you're bored, you're sitting down, you have a needle, you like stick the needle through the skins of your palm. You ever do this? And you could actually see the needle through the skin. You know, when I was like 6, 7, it was like the rage. Everybody was doing something around showing people needles sticking out of them. So the layer you're sticking the needle through is the stratum lucidum, right? Now the lucidum is important because lucid means clear. So right, when a doctor says to somebody they're lucid, means that they're not foggy, they're not mentally foggy, they're mentally clear, right? So stratum lucidum is a clear layer of cells. You can stick things in and still see them. You know, that's what you want to do. It says here, 5 rows of clear, flat, dead cells, right? Now, the last row, this is the outermost row now, is going to be the stratum corneum. And if you notice, it is the thickest. 30 rows of flat, dead cells, which are keratinized. They're filled with keratin. Now, obviously, if you're packing them full of keratin, and you have the thickest layer of them, this layer is primarily focused on protection, right? You've all had a corn or a callus at some point in your lives, right? Maybe the shoes you buy too tight, you know? When I was growing up, there was a song that taught us all that it is important to wear your appropriate size shoes. But I suppose such knowledge has been lost to time. When you wear a pair of shoes that's either too small or even too large, it causes undue pressure on the foot. right? If your shoes is too large as you're walking, your foot is moving up, especially your heel, the back of your foot. And then when you put your foot down, it scrapes down against the back of the shoe. And over time, that causes abrasive damage. And what does your body do? It generates more rows of cells in the area where that constant abrasive damage is occurring. And that, of course, is how you get a corn. Hence, stratum corneum. If the shoe is too tight as you're walking, once again, the back of the heel is squeezing too tight on your shoe. As you put your foot down, the shoe deforms slightly because of the weight of your body. When you lift your foot up, the shoe goes back to its original position and squeezes and scrapes the back of your foot or the front or your toes, depending. And over time, once again, you get a corn, right? So if your shoe is too small or too large, you can still get corns, right? And if you actually do physical things for a living, you lift block, you mix cement, as you're working with your hands are constantly scraping on things. And over time, you develop calluses. A callus is basically a large flattened corn over a large area of your body normally, the hands or feet, which are there for protection, okay? All right. So here are the layers in their correct order. Remember, basal layer is the lowest level, right? This one has the melanocytes and the Merkel cells in there. Then you have the stratum spinosum here, right? You can see that it has little points on the corner. They say it's a little spiny. Remember, these are filled with melanin, protection against UV. You have the granular layer here, stratum granulosum. So there's about 3 layers of those, right? And then above it, you have the stratum corneum, right? Filled with keratin, which of course means these are dead cells and their protection against abrasion. But because they are dead cells, also means it's protection against infection too, right? Now, this is a lovely slide of the whole setup. You can see here that is our if you follow here, basal layer, then our spinosal layer, etc., right? And then you have all of this corneum. This is one of the things that we should have done in the lab when we never got a chance to. Now, so those are the major layers of the epidermis. Then moving on to the dermis now. Remember now, the dermis is the middle layer. This is the layer that's going to have a lot of the structures that you'll find in the skin. Epidermal layer has lots of cell layers, right? But now in the dermis is now you're going to find glands and other things like that, right? So as it says here, oh, I should mention, I know you know this already, but let's just make sure I mention it. Epidermal tissue, as you know, all epidermal tissue is avascular. I'm sure you know this already from A&P1. Let me just remind you, it is avascular. There's no blood vessels running through the epidermis, which is why you can get a scrape on your skin and it will not bleed as long as the scrape is not too deep. If you get a scrape and it bleeds, it means that you've broken through the epidermis. You've moved down into the dermis of the skin. Right? And the scrapes that bleed are the ones that are more likely to get infected because you'd have scraped away the protective layers. Okay? Okay, so what's in the dermis? The dermis is made up of quite a bit of collagen and elastic fiber for its structure. Collagen, as you know, strong fiber and is good structural material. So it helps your skin to hold its shape, right? The elastic fiber allows your skin to stretch. So when you pull on the skin, it pops back into place. So between the two of them, your skin will hold its shape under, sorry, will hold its shape. And if it is deformed by sitting down or whatever, somebody poking you in the skin, it goes back to its normal position, right? Now, it also leads your skin to have extreme elasticity. Think about when a woman gets pregnant. Ever see like a woman with like triplets or so? Walking around the place, the belly in front of her is almost her height, right? But the skin manages to stretch to accommodate this massive pregnant belly, right? Now here's the thing that you may not have realized. The younger a woman is when she has her children, the more elasticity and the more collagen there is in her skin. So the more likely it is for her to completely recover. So when she has the baby, given enough time, the skin that was stretched out too much will be properly reabsorbed and go back to its original position. It's also less likely to get stretch marks. Stretch marks are a sign of skin damage. Stretch marks normally happen when your skin is stretched rapidly. Okay? So if you, for example, gain a lot of weight over a summer or whatever it is, your skin isn't given the time to stretch out properly. So it actually tears. And as its skin tears, you put scar tissue in the damage because that's the quickest way to heal it. So that's a stretch mark is actually a scar. Okay? So if you, as I say, if you gain weight rapidly, or if a woman gets pregnant and obviously the belly going to get big, but once again, the younger you are when it happens, the less likely you are to get stretch marks. And before anybody asks, all the cocoa butter in the world is not going to do a thing for your stretch mark. All right? I don't know where this rumor came about that cocoa butter help with stretch marks. It does no thing. All right? Now, as it mentions here, the upper layers of the dermis consist of, listen, you can put any oil you want on it. I'll put some, so I saw one person talk about use raw egg and vitamin E. Knock yourself out. All the collagen powder in the world, it does not matter. Why doesn't it matter? It's very simple. The stretch marks are popping up not because you're low in collagen or because you need egg on the skin. It is because your skin is being stretched rapidly and it is overcoming your skin's ability to reproduce itself. Simple as that. There's nothing you can do about it. Right? All the cocoa butter in the world, all the collagen powder in the world, not going to do one thing. Right? It is what it is, right? Besides, if you're getting a stretch marks giving birth, hey, what's the big deal? Right? You earn those stretch marks. You earn them. Right? All right. Moving on. Now, upper layers of the dermis are going to consist of areolar connective tissue. Of course, you earn them. Now you carry the baby and the baby stretch out and you have to deal with the whole trouble. So you earn those stretch marks. So they're a sign that you did something. Right? Birthing a baby is a thing. It's a hard thing to do. Those are your badges of honor. Move on with your life. Now, dermal papilla. Oh, wait, sorry. Dermis consists of areolar connective tissue, right? So, as you know, areolar connective tissue is one of the most common types of connective tissue. It does a lot. Its main job, really, as I say, is to connect in this case, your dermis to the hypodermis, as well as to the other structures within the dermis itself. Okay, so we're talking about like the hair follicles and stuff like that, right? Okay. So you also get the areolar connective tissue helping to form the dermal papilla. Right? The dermal papilla are what give you your fingerprints. Okay? So obviously this is going to be on the palms and on your palms. Well, obviously the fingers, soles of the feet. You have these little ridges. You all know what fingerprints are. The purpose of the fingerprints is very simple. They're there for purpose of gripping. All right? They increase your ability to hold on to things. That's why then you're on your fingertips, they're in the palm of your hands for grip. That's why they're on the bottom of your feet. Right? That is why sometimes you'll find that walking barefoot, you slip less than when you're in shoes. Because your feet have literally evolved over a million years to the perfect platform to walk on. Right? Where your shoes have not. I can't think of any shoes that better than your foot bottom. Anyway. Now, it also mentions here that you have dense irregular connective tissue, adipose tissue, hair follicles, nerves, oil glands, and sweat glands, all within the dermis. Okay? So as I said to you, the dermis is very active. Lots of things are going on. And you know what is funny about shoes? There's more and more evidence showing that if people wear too much shoes, they have bad posture. Right? Their feet don't develop properly. Because the way you walk in shoes is unnatural. When you walk in shoes, you put your heel down first. Right? And then you lower your foot. That is unnatural. When you do that, you put more pressure, more physical force on the heel, which runs up the spine. So if you're walking around all day in shoes, you find you get a backache, right? Whereas if you're walking heel and you put down your toes first, then the heel, you're absorbing the impact. And then you find actually you get less pain. I guess what I'm saying to you, if you're introduced to shoes too early in your life, you do not learn how to walk properly. So when you do put on shoes, so when you take the shoes off, you still walk improperly, which means you're dropping your heel on the ground, even barefoot. So you find yourself constantly putting on shoes because your back hurt you. All right? So my advice is, hey, for the first couple of years of a child's life, no shoes. Let them learn how to walk properly. Then you can give them the shoes. Anyway, I mean, when I'm at home, I don't wear shoes. Right? Even when I'm going outside my yard, I'm not putting on no shoes. Which is not a great idea. Anyway. Now, Pacinian corpuscles, which we mentioned before, they're great for sensing pressure, right? As you know. So remember, all of these lovely things that you're going to find in the dermis, right? Adipose tissue, hair follicles, nerve endings, remember, for pain, oil secreting glands, sweat secreting glands, right? And we have Pacinian corpuscles. So this is where a lot of the functions of the skin are coming from. Then now, let's talk about skin color. There are three main substances that color your skin. Melanin, which is by far the most important. Keratin, which is secondary importance, and hemoglobin. Okay? We all know melanin. That's a nice, easy one. Melanin made by the melanocytes. By the way, melanin itself is a brown pigment, right? Which means that melanin cannot give you black skin. Melanin can make you extremely brown if it's very concentrated, but you're technically not black, right? And again, at some point, the brown is so dark, it can be a little difference, right? Keratin, on the other hand, is a yellowish pigment, right? And you've heard of beta carotene, like in carrots, it's the same stuff. Well, carotene, not the beta carotene, but it's the same basic stuff. which of course gives your skin sort of a yellowish, orangish color. So if you're a person with light melanin content, right, but heavy keratin content, your skin will have sort of a slightly yellow look to it, right? You know, people say, boy, if you have jaundice, you have like a yellow-green look to you. That's because of the bilirubin. That's not the same thing here, right? Now, here's the thing with albinism. When I say albinism, of course, I mean we're talking about albinos, right? So an albino is somebody with a genetic condition which makes their melanocytes ineffective. By that I mean they're not able to produce functional melanin. And when you can't produce functional melanin, it means that no place where melanin should be stored will have melanin in it. So when you look at an albino, their skin isn't really white because there's still going to be other colorings in there, for example, hemoglobin, etc. But they will look extremely pale skin, even in comparison to a quote-unquote white person, right? But also, their hair is also going to be white. Why? Because it is the melanin that also colors your hair. Their irises are not white, but they look pink. Why is that? It's very simple. Our irises, the reason they're really dark brown or whatever color they are, is because of the presence primarily of melanin. When you remove the melanin from the irises, you still have lots of blood capillaries running through the irises. And of course, the blood capillaries have blood in there, which of course makes everything look pink or red. So when you look at the albino's eyes, they have that pinkish color to them, right? So that is all because of lack of melanin. Somebody is asking why your skin gets darker and your hair gets lighter in the sun. It's very simple, really. The sunlight actually destroys melanin, right? So it literally bleaches your hair by destroying the compound melanin itself, right? But your skin gets darker because as your body realizes more UV radiation is coming in and the melanin is being damaged, your melanocytes start to produce a lot more melanin. So they go overboard. And then they move that melanin, of course, into the stratum spinosum, which helps to darken your skin because it is a means of protecting yourself from UV. Coarse feeling in the skin is a bit vague. There are lots of different things that can cause that. All right? So a suntan, as it rightly puts here, is what we're basically describing here. Generally speaking, when you get a tan, as in your skin darkens, it is a sign that you have taken UV damage and your body is trying to prevent further damage, right? Which translates it is not a good thing. Darkening of your skin means you're getting damaged, okay? All right. Freckles. Freckles, of course, freckling is caused by also UV damage within patches. So not all parts of your skin are going to get exposed to the same amount of UV radiation. So in some places you get a bit more than others, and because of that, you end up with little patches showing areas that are getting darker. Once again, the darkening is a sign of damage. So if your skin gets freckles, and black people can get freckles, it is also a sign of UV damage. Okay? I will talk about why that is bad in a little while. So I already mentioned keratin, put in the skin as a pigment, gives it a yellowish color. I should also mention that most of the keratin is coming from your diet. All right? So if you consume very large quantities of food very rich in beta carotene, you can actually see your skin color change. In the, I think it was like in the 90s, You know, when you live long enough, you see all kind of weird fads come and go. In the 90s and early 2000s, we had two weird fads. One of them was that people were convinced, for whatever reason, I never really understood it, that carotene was like a super antioxidant and you must consume as much of it as possible and it will make you super healthy, right? So people used to buy carotene pills and take them, and what had happening is that white people all over the world are turning orange. I mean, literal orange, right? Because the carotene was being deposited in the fat under the skin, and it showed up through the skin, so they were literally changing color, right? Then you also had people who were convinced blueberries were the new superfood, and they would take blueberry extracts, and once again, the blueberry extract, some of it would get deposited under the skin, and they would turn blue, right? So I had people running around look like they were coming from The Simpsons, and someone who looked like Smurfs, right? The 90s were an interesting time. Anyway, somebody asked me something about chlorophyll. I don't understand what that question is. You're gonna need to rephrase that. All right. Then we have hemoglobin. Hemoglobin, of course, is coming from the blood. So wherever you have lots of capillaries near the surface, once blood flows into those capillaries, it's going to make the skin look kind of reddish, right? And which is where the erythema comes in, which is the redness of the skin, right? Which once again caused by increased blood flow. So this is what we say when we say, oh, somebody's blushing, the skin starts to look, if they're light enough, the skin starts to look reddish, all right? Or if they're light enough to get inflamed. If you're wondering, even if you're dark skin, you still can blush. It's just not as visible because of the melanin in your skin. You still feel, for example, when people blush, they say, boy, the cheeks start to feel hot. Why? Because warmer blood is going into the skin. So your skin feels warm, right? So it gets red, it looks warm, so you're so embarrassed. The same thing happens to a darker skinned person, it's just that you can't see the redness, right? So remember, erythema, that's the redness of the skin. Example, blushing, right? Now we have what we call accessory organs. Once again, accessory organs are not directly a part of the system you're looking at, but they contribute significantly to the system, right? So the hair on your skin is considered an accessory organ, right? If you shaved all the hair off your body, would you die? No. I mean, do you need the hair to survive? No. Does it help? Absolutely. For example, think about the function of the hair on your scalp. We're not going to worry so much about the hair on the skin yet. What does the hair on your scalp do? It protects you from UV radiation. It also protects you from temperature changes in the environment. Okay? Now, let me explain what I'm talking about. Somebody mentioned injuries. Sure. No, your hair cannot block a flipping bullet. I don't care how many years with a rasta you grow. All right? Okay.
Miss, sorry, tell that to Rita.
Rita who? Marley?
Yeah.
Look here. If you could have 50 meters worth of dread, one bullet start right out and make a difference. All right? Now, see this makes sense. There's a difference in the hair of, let's say, Caucasian people. I don't like saying white people because it's stupid. I've never actually seen a white person. The whitest person I've ever seen was an albino. Have you ever met Caucasian people? They're not white. They're pinkish blue or teal or all kind of weird colors. But I've never seen a white one. Right? Now, yeah, well, I mean, they might look pale, but they ain't white, right? Listen, I come from Treasure Beach, right? Some people in my family lighter skin than half of the white people I know. So whatever. But they're still considered black people, right? So I want to get involved in that. So the hair of a Caucasian is different from the hair of a, I'm going to use the word Negro because there's nothing wrong with the word Negro, right? Why? The hair of a Negro was evolved in Africa. What do you have in Africa? Whole heap of sun. So the hair has to help alleviate issues with the sun. How does it do that? First of all, the average person of African descent, your hair, number of hair follicles you have per centimeter squared is less than somebody from Europe. What does that mean? It means your hair is, they have fewer hairs. Okay? Why is that important? Because it allows air in. All right? The hair is curly. Why is it important? Because the curly hair allows, once again, hot air. Remember, I'm saying hair and air. Remember, the curly hair and the fewer hair follicles allows hot air to leave the skull around the head and go back into the environment. It helps you to keep cool, right? And the black hair obviously also absorbs UV radiation as well. All right? So your hair as a black person is designed for hot environments because of those two things. Helps to keep your brain cool. In Europe, they're not worried about the heat. What are they worried about? They're worried about the cold. So their hair is, first of all, there are more hair follicles per square centimeter. So they have denser hair. And the hair lies flat. Why? Because it's acting as an insulating blanket. It helps to hold heat now nearer to the brain. So it keeps the brain warm. So that an African person's hair helps to keep their brain cool, and a Caucasian person's hair helps to keep their brain warm. Which is why I don't understand why people in Jamaica, women in particular, not straighten their hair. You're defeating a million years with the evolution for style. What sense that make? Some are coming in, so I don't know with them long old braids in their hair. I'm sorry for them. Right? Because you know you're gonna smell bad. And you can't wash it. Anyway, let's move on.
What gonna smell bad, sir?
Okay, I just want to mention something to you. You know this Jamaican proverb, if you fling stone in a hog pen, the one will squeal. Let's move on. Now, eyebrows. What do you need eyebrows for? Think about what an eyebrow is for. Look where it's placed. It's placed above your eyes. And as you rightly say, Shamar, as you're sweating, sweat comes down, hits the eyebrows. But remember, think of the way the eyebrows are shaped. They're curved, right? The position and the hairs themselves follow a curve around the skull. So they direct sweat away from the eyes onto the sides to run down the side of your face instead of down to your eyes. Which is why you have eyebrows. It's a means of protecting your eye from sweat. Eyelashes, what are they for? To reduce sand and dust getting into your eyes. Right? Now, Caucasians, once again, that live in cold places, tend to have longer eyebrows because they're useful for blocking out like snow and all kind of other things. They're also required because people don't realize this, but if you've ever been around snow, snow is extremely bright during the day. I don't know if you've ever heard this term snow blindness. Right? But if you're out and about during a very snowy, sunny day, you can actually get burns on your cornea because the sun is being reflected by the snow up into your face. And it damages your cornea. So having longer eyelashes that you can squint, it can prevent the snow from coming in, and it can limit damage from UV from being reflected up. That's why when you see people going skiing, they have on they wear the ski goggles, right? The ski goggles are there to stop snow from getting in their eye, but also they're polarized because of the UV. Okay. Then we also have hair in your nose. Once again, people of Caucasian descent tend to have more than people of African descent. Why? Because once again, snow. You're filtering out larger particles out of the air you're breathing in during a snowstorm or something like that. Right? In Africa, yes, you'll have the occasional dust storm and things like that. But it's not like it's something you must encounter during your life. If you live in Germany, you must encounter snow, you don't have a choice. Right? And many months worth of it. Okay. So that's what the nose here is for, filters, right? Okay, so that is the function of the hairs on different parts of the body. You'll notice I have not mentioned the hair on the rest of the body. Only the hair on the head. Because most of the hair on the rest of your body is not functional the way it should be. A long time ago, our distant ancestors were very hairy, and that hair would have had a function. But the little fine hairs we have on our skin are pretty much useless. They don't really do anything for us anymore. The hair under the armpits and the groin is a secondary sexual characteristic. All right. So real actually we should talk about that with reproduction. I'm going to mention that a little later on though. All right. Now, let's talk about the structure of the hair itself. I am not expecting you to know very much more than this, okay? We're going to be very conservative in what I'm teaching with regards to the skin because time is a factor, right? So as it says here, each hair consists of a shaft, which of course the part, as you can see, is above the skin, the root, which is the part that is penetrating through the dermis, right? And you have the hair follicle, which surrounds that root. And hair follicle has two parts, external root sheath, and an internal root teeth. Okay? Then the bulb now is the base of the hair follicle. And inside the bulb, you're going to have the papilla. And the papilla is basically where the hair is growing from. Right? So, and sitting in the papilla, you're going to have the matrix. So the papilla of the hair is going to provide now the matrix with all the nutrients and nourishment required for the hair to grow via mitosis. Go ahead, Tessie, your hand is up.
Sir, the bulb is like what they say is like the base of the hair.
When you pull the hair out of the head, if you pull it out properly, see the whitish thing at the end?
Yeah.
That the bulb is contained within that.
Okay.
Assuming you pull it out all the way. Oh, by the way, this is also the reason why plucking hairs, they take longer to come back than if you cut them. When you pluck out hair, I can see some people pluck their eyebrows. They're pulling out the hair, and if they pull out the root as well, it's harder to regenerate that hair. So plucking hairs, it takes much longer for them to grow back than if you cut them, right? So this diagram, of course, of the hair structure, yes, once again, you're expected to know how to label because you do have a skin lab quiz coming up, right? Now, the hair also has connected to it two structures. You have the arrector pili muscle, right? Which you know from CSEC. PI. Arrector pili, right? Or arrector muscle, as it says here. This is the one that gives you the goosebumps, okay? So when you get scared or cold or whatever, the arrector pili muscle pulls, as you can see here, on the shaft, and that causes the hair to stand up straight, right? Why does it do this? This is what we call a vestigial structure. Vestigial, of course, is a structure that used to have a function back in the day, in the past, but doesn't really have a function anymore, okay? So what does causing hair to stand up do? Back in the past, when your ancestors were very hairy, when they got cold, the hair would stand up straight. This would trap a layer of air near their skin, which their body would warm. And that warmer air would form a protective blanket over their skin. Our hairs can't do that anymore. They're too thin and too few, right? So the goosebump you get when you're cold is basically pointless. Now, obviously, this can also be affected by emotions, right? Not just in humans. You know, cats, when cats get vexed and hair in the back of the cat back stand up, you know, it makes the cats look. The idea is that they also have erectile pili muscles, and they cause their own hair to stand up because it makes them look bigger. That's also why the cats arch their back when they're, vexed with one another, because they want to make themselves look as big as possible. Now, so when human beings get nervous or afraid, it can also cause the hairs on our skin to stand as well, right? Once again, it's kind of useless because we don't have very much hair. We also have sebaceous glands. And the sebaceous gland has a duct here that goes right into the hair shaft, this is, of course, the hair follicle, right? So the secretions go straight onto the hair, and then from there it gets moved onto the skin, right? And so the sebaceous glands are producing oil for the skin, and the oils help to reduce loss of water via evaporation to the skin, okay? Now, obviously, because it's dumping its substances directly into this little narrow passage here, there's an issue with blockage. Let's say bacteria get down into the shaft and then start feeding off the sebaceous secretions here. They can actually cause a blockage, right? And as the sebaceous fluid, as the oil builds up, the area around the hair starts to swell up. And then the oil itself starts to oxidize and turn black. And all of a sudden you have a blackhead, right? So it's black because it's oxidized oil coming from a blocked up sebaceous gland. So when you squeeze it, it pops out and you see a little black thing on the top. That's the oxidized oil. Squeezing it, of course, unblocks the passage, hopefully, so it will heal. A whitehead now is basically, once again, a blockage, but it's an infected blockage. And that infection is being fought. The reason it's white is because you have pus in there. Which means you have bacteria, you have bits and pieces of cells, you have various different white blood cells, mainly neutrophils and macrophages, all in that mix. So when it squeezes out and it pops out, what you're seeing is infected material, right? All right. Hair growth. By the way, if you've ever seen anybody with like really, really bad acne, when I was younger, I used to say they have pizza face. These days, you don't, when you're treating that kind of acne, we don't just say you go wash your face with various kinds of things. You give them antibiotics because their faces are infected with a bacteria, and the antibiotics are necessary to knock back the bacteria to a low enough level that their own immune system can take it over, right? Somebody mentions Accutane, right? Now, think about it. There is a reason why pretty much everybody finds acne to be disgusting. Let's be honest, we all find it disgusting, right? It's not the person's fault, but think of it from this perspective. This person is infected, right? They're presenting themselves into a crowd of people with an infection. They're automatically going to look, say, hey, this person is less fit, right? This is your primitive mind thinking. Can you imagine 20,000 years ago, you and a small group of people, one person's face is severely infected. There's no Accutane around the place. What's the chances are that they'll get a serious infection that will transfer to into their blood and it will kill them. So what do? You avoid that person. All right? So there is a reason for our prejudice, but of course it is prejudice, right? Now, growth cycle. Your hair doesn't just continue growing throughout the entirety of your life, right? Depending on where the hair is coming from, the length of the hair and how long it takes to get to that length will vary. For example, we know that the hair on your skin only grows a few centimeters, right? Doesn't get very long. The hair on your eyebrow, slightly longer than the hair on the skin, but not by a lot. And then it stops growing. The hair on your head, believe it or not, most people, there's a maximum length to which the hair on their head will grow, right? So let's talk now about how we get to that. As it says here, in the growth cycle of the hair, you have what is called the anagen phase, which is the growth phase of the hair. That can take up to 3 years, okay? Then we have what is called the resting stage. So the hair grows for 3 years. Then for 1 to 2 years in the catagen phase, it doesn't really grow anymore. It just sits there. Then it eventually falls out. Sorry, it transitions, I should say, into the resting phase. And at the end of the resting phase, the hair falls out. Somebody asked about male hair growing fast. One of the things that impacts hair growth is actually testosterone, right? Now, that said, testosterone is also responsible for the hair falling out. So it's kind of a weird thing, right? Now, hair follicles grow as this is in cycles, right? One cycle can be broken down in 3 phases. Remember, anagen, hair is growing. Catagen, the hair has basically, well, what I should say, catagen, it has slowed the hair growth down. Telogen, the hair is not growing anymore. It's resting. And in the end of the telogen phase, the hair normally falls out, right? Remember, your hairs are in the cycle right now. So it's hard to tell which hair is in what part of the cycle. Once the hair has fallen out and is regrowing, then we can say, yes, it's starting at the anagen phase. But most of your hair follicles are going to be in the catagen to telogen phase at any given time. No, sorry, 85% are in the growing phase, right? I should say. So the bulk of the your hair is growing as we speak, right? 85% of it. And then once it stops growing, then that's like your eyebrow hairs, they get to a certain length and then they stop. And then eventually they fall out and you replace them, okay? All right, so 85% of the hairs, growth phase, and in given time, and it can, as it mentions here, up to 6 years in this case, and hair grows up about 10 centimeters per year. That said, the hair is unlikely to grow more than 1 meter in length, usually. Once again, some people, their hair can get extremely long, particularly the hair on the head, right? At the end of the anagen phase, the hair will enter the catagen phase, and this is about 2 weeks. And during this phase here, the follicle shrinks to about 1/6 of its normal length, and then the lower part, which is near the dermis, will break off, right? And when that happens now, it goes to the resting phase. And that's about 6 weeks, and hair doesn't grow, but the hair is still attached, right? Then during that phase, the dermal papilla is resting, okay? And around 15% of hairs are in this phase at any given time. At the end of this stage now, you re-enter the anagen phase, and then the hair that is there has to fall out as the new hair starts to grow, right? And rinse and repeat, okay? Now, remember, this is the norm. Yes, you can point to some people with hair as like, I think the record for hair length is what? 6 meters, I think it is. It's like 20 feet or some ridiculous length. It's actually held by this Indian guy. Well, he apparently, according to him, he's never cut his hair. He's like 90 odd years old, and his hair weighs about 30 odd pounds. So he has to wrap it. Anyway, now that said, let's talk about some glands. There are 3 glands you need to be aware of, 2 of which I mentioned before. We have the sebaceous glands, which are the ones that produce the oil for the skin. And we have the sudoriferous ones, which of course are your sweat glands. This one here you may not have heard of before, and those are your ceruminous glands. These are the ones that make earwax. And earwax is actually very important, right? So, sebaceous glands. You do not have sebaceous glands on the palms or on the soles of your feet. I'm hoping that it is obvious to you why that is. You can imagine you're trying to climb a coconut tree and your hands and feet are constantly oily. That would be a problem, right? You can imagine you're trying to climb up the side of a hill and your hands and feet are constantly oily. So obviously, not having oil on your fingers is a good idea. Now, the sebaceous glands, what they secrete is called sebum, right? And as we mentioned before, it stops your skin from drying out. It also helps to keep your skin soft, and the sebum itself also contains antibacterial chemicals, right? As you get older, the amount of sebum you produce starts to diminish, which is one of the reasons why older people's skin looks drier, right? If you think about it, we always see using the very expensive skin creams. It's not people in their teens. It's people in their 40s, 50s, and upwards because their skins are drying out, right? Now, when a sebaceous gland on the face becomes enlarged, of course, we mentioned blackheads already, right? As it says, increased melanin and oxidized oil is what gives you that dark color. Then pimples now are, as we mentioned before, bacterial infections. Now, we already mentioned here you have your hair follicle, right? Here's the sebaceous gland, making the sebum, dumping it into the shaft, and it goes up and out onto the skin, right? Now, sweat glands. You actually have 2 types of sweat glands. You have the one which you're very, very familiar with. That's the one throughout the entirety of your body. I think it is an EMP1 as well, which is the eccrine sweat glands. These are the ones that produce the very watery sweat that you're used to, okay? In specific areas of the body, the groin, armpits, you have these apocrine glands, and they don't produce sweat in the traditional sense. They're not trying to cool your body. These apocrine glands, this is where you get, it is filled with various proteins and lipids and even some glycoproteins, right? And the substances in these areas generate smell. Their purpose is to produce a smell. Why do you have glands on your body that make you smell? Now, if I say to you, it is for the same reason why dogs sniff each other's butts, that would seem like I'm making an insulting statement. But it is actually true. Why do you think dogs are sniffing each other's butts? They want to smell poop. There's plenty of poop outside. So why are they doing it? Because the dogs have special apocrine glands around the anal region that produces substances that gives other dogs information about the dog they're smelling. It allows them to identify each other, to determine each other's sex, If it's a female dog, to determine if the female is in heat, to determine relative health of the animal, all sorts of things. So they sniff each other's butts because they get lots of information. Right? So why do human beings have it? We don't generally run around sniffing each other's butts. Unless you're into that sort of thing, I suppose. Because, once again, this is another one of these things that always is vestigial. Your distant ancestors had much better sense of smell than you do. And we also would have produced even more substances from our apocrine glands. And these substances would have done the same thing it would have done for the dog. It would have allowed us to say, hey, this woman, this female is an adult or not an adult, right? Some people believe that these substances would also contain pheromones. I don't know if you've ever heard of pheromones. Pheromones are sex chemicals, sex attractant chemicals, right? They're supposed to make people more sexually interested in the person who's producing these pheromones. Now, human beings, of course, have an absolutely lousy sense of smell, right? Absolutely lousy. There are very few animals on the planet with a worse sense of smell than human beings. But even with that, there was an experiment that was done a few years ago now, where this was done at a university, of course. They got, I think it was 100 females, and they gave him a cotton t-shirt to sleep in for a week. Then they took the t-shirts, put them in plastic bags, and then got males to come, and they were told to smell the bags and rate the way the females smelt and determine and enlist them in terms of their attractiveness. Remember, they're not seeing these people, they're just smelling them. You'd think to yourself that this doesn't make any sense. How are they making a difference? What, pretty people smell different? That don't make any sense. But guess what? What they realized was that, for the most part, males listed in order of how closely related people were to them. By that I mean, they found the smells of the females that were least related to them more attractive than the ones that were. So some of the people, for example, would have had like a sister or a cousin in the mix. Those always went down to the bottom of the list. Whereas in the females who, for example, from another country or so, they were closer to the top of the list. So the apocrine sweat glands, even though on a daily basis, you can't really distinguish the chemicals they're producing, they're still producing something, because we can still pick up something from them, right? Which is why I guess they have not vanished, okay? All right. That was a long diatribe. Hopefully that makes sense to you. That's why we still have apocrine glands. They do produce some sex-related chemicals. Even though we haven't been able to isolate them, we are still, even if it's only subconsciously conscious of their presence. This is also, you ever watch like TV shows and you see guys, they're getting ready to get it on with a woman and take off them underwear and fling upon the man, what the man then take it and sniff it. This must be smelling something, right? All right. Now, and again, I saw this one thing on 9gag where this woman threw the guy a pint and he smelled it and he vomit. That was hilarious. Anyway, now, Cereminous glands. Remember, these are the ones that produce earwax. Most people, when they talk about earwax, oh, earwax is so nasty and whatever. You have people, when they look at earwax, they want to vomit. I'm like, all extra so. What is earwax? What is it? It's a protective mechanism. The earwax in your ears is there to stop insects from taking up shop in your ears. And it is there to reduce water loss. Here's what I mean. Wax, of course, is waterproof. So lining the ear canal with wax reduces the loss of water through evaporation. That's one thing. But this earwax is also contains antibacterial chemicals, which reduce the chance of you getting an infection, which is always good. But it also tastes bad to insects, right? It tastes bad to insects. Why are you lining your ears with something that tastes bad to insects? Because insects, like so many of us, like warm, moist holes. And so because of that, if you lie down, insects are prone to want to crawl into your ears, into your ear canals, right? But they won't stay in there because it smells bad in there because of the earwax. And when they try to clean the place, they walk up and down in the earwax and get it on their legs, and they clean themselves by, of course, using their mouths. They get this bad taste in their mouth, so they leave, right? Insects will, generally speaking, not stay in your ear canal. So it makes sense, I should hope, that the earwax is there. So if you are one of these people who are constantly cleaning out your ears, right, you're reducing your ability to defend against insects. You're increasing your chance of getting an ear infection as well, right? For the most part, what will happen is that the wax will dry, crack, fall out, and then you won't have to clean your ears. Though in some cases, you can get blockages, in which case, what do people normally do? They reach for what do you call it? A Q-tip, and then shove down into the ear canal, slam right into the tympanic membrane, and cause damage. Talia, your hand is up.
Sir, when I was attending primary school, there was a little Indian girl that feel like she was tush, and the wax in her ears was so much that it was showing on the outside, and that was very nasty, sir.
What do you mean it was showing on the outside?
Yeah, like you can literally see it.
No, but if the wax is that thick, she's basically deaf on that side.
So, oh God. So why should not clean out her ears, sir?
May I ask? As I said, sometimes it happens and it gets blocked up in there. But what you're supposed to do is okay. As I was about to mention, like the Q-tips and these kind of things, you're really not supposed to shove them down in there, because what normally happens is that you end up pushing the earwax down against the tympanic membrane, which means it can't vibrate properly, which makes you basically deaf. And of course, the Q-tip itself can push through and actually damage your tympanic membrane. There are cases of people who are so aggressive with it, actually burst their eardrum, their tympanic membrane, and cause serious damage to their ears. If your earwax is built up, what you're supposed to do is take some warm water and dribble on the ears, and all right, and do this several. It's going to take a while, but several treatments a day over a period of several days should cause the wax to absorb enough water to start falling apart, and then the wax should leave your ears. Right? Also, if you people who swim regularly, they tend not to get a buildup of wax in their ears either. Right? Anyway, I'm just saying, don't shove things in your ears if you can avoid it. And I've seen some of these metal things that selling online to clean ears with. So boy, you're really asking for trouble. Anyway, fingernails. Your fingernails now have three main parts. You have the nail body, which is the part that you can touch. You have the free edge, which is the part that sticks out from the body, right? And you have the nail root, which of course is what the nail body sits upon, okay? Generally speaking, your fingernails tend to look kind of pink because of blood under them. Once again, depending on how dark your skin is, the color might vary a little bit, but the color is always going to be lighter than that of your skin, right? Now, near where the nail body meets the edge here, you have an area here called the lunula. Now, once again, depending on how dark your skin is, the lunula might not be so clear. All right? This right here. You can look at your fingernails and tell me if you can spot this area. It's supposed to be, it doesn't have to be this thick. but it's supposed to be a lighter colored area, right? That's what they call a lunula. I'm looking now and I'm seeing it most clearly, you're right, on my thumb. Now, if you're in a place with air conditioning where it's a little colder, it might be a little more obvious, right? I'm not in an AC room, so. So here we have the free edge. That's the part that sticks out. You have the nail body, which is the part that sits on top of the nail bed. All right. Then, of course, on either side, where the ingrown nail, that's the nail groove. All right. We have the lunula, which, as I said, is the little area of the nail that is lighter in color, which is near the cuticle. All right. Notice the cuticle here is this little fold that is there to seal off the nail from under the nail fold here, okay? The cuticle is there to prevent bacteria and other things from getting from the nail under the skin, right? Should be, I'm hoping it's obvious to you why you don't want bacteria under your skin. Now, the reason I mention this is because I'm being told, I mean, I've never actually been to a cosmetologist, so I don't know for sure, but I've been told that they'll sometimes, when they're cleaning the nails before they paint the nails, they'll clean under the nail fold, right? They'll actually push the probe up underneath the cuticle. You're not supposed to do that because you'll push bacteria up underneath there and get infections, right? And if you think about it, the same probe they're using to clean your nails, you're not supposed to push on it at all. Right? How you know the probe that they're using to clean your nails? They never used to clean 10 million other people's nails. And then they didn't clean it in between. You don't know. Right? So, and even if they did clean it, you're still shoving in and opening a space underneath the cuticle, which makes it easier for bacteria to go in. So, whatever they're doing, they should not mess with the cuticle. You're just going to end up with an infection. But why are they cutting off a bit of the nail fold at all? You're not supposed to do that. Once again, if you do that, it's easier for bacteria to get in. All right? They can do what they want with the up here, so no problem. But nothing beyond this point they should ramp with. Okay? If you want, you can paint the lunula too. Paint it all you want, but no sharp implement should be entering any part of this. Right? Think about it, particularly for the feet, and which you'll be shoving into shoes. And of course, think about what is the shoes. Shoes is an enclosed area which is very hot and sweaty. Bacteria couldn't ask for a better place. And now you have spaces underneath your cuticle for the bacteria to come in. Right? So no, you don't do that. Anyway. That said, let's talk about healing of your skin. Right? Now, this should sound very familiar to you because when we did the blood vessels, we spoke about well, let's see. Let's see. We spoke about things like edema and those kind of things already, right? So you, for example, it says injury. When you get an injury, you get inflammation. What causes inflammation? You're looking at cells like your basophils and your mast cells causing inflammation. Why is inflammation important? Dilation of nearby blood vessels increases the blood flow to the area. And of course, more blood going into the capillaries makes it look more obvious to the skin, so the area looks redder. But the dilation allows white blood cells to enter the damaged area more easily. Right? And more fluid leaks out of the blood in this area and goes to the tissues, which is why the area swells. And as the plasma is leaking out of the capillaries into this damaged area, it's carrying the white blood cells with it, right? And of course, that buildup of fluid, which causes the swelling, also puts pressure on the pain receptors in the area, which leads, of course, to pain, right? So obviously, the extra blood coming to the area is also going to be bringing nutrients to the area, which makes it easier for the skin to repair itself. As well as we mentioned before, extra white blood cells, right? This should also unfamiliar to you already, right? And you already know about blood clot formation and scabs and all of these things. I won't even bother going through it because you know it already, right? All right. How many slides do you have left? About 15 slides. All right. Here's what I want to do, folks. I want to finish up the 15 slides here. And then I want to take 20 minutes and come back and at least start hormones. Because I need to try and finish it for Friday, all right? By the way, I've posted tutorials on the remaining subject areas. I have posted them with the answers because I figure we're not going to have time to go through them. Please run through the tutorials. I have reused some of the questions on your in-course test. That's all I'm going to say to you. All right. Collagen, as you age, collagen fibers decrease. I mentioned that to you already. Elastic fibers decrease. I mentioned that already to you. And which is what leads to wrinkles. Now, if collagen is decreasing and elastic fibers are decreasing, logic dictates that if you increase your consumption of collagen, right, and protein, you're supposed to cause your skin to fight the aging process, right? That sounds perfectly logical, right? And anything that increases collagen to your skin is supposed to make your skin age more slowly, right? No. No. When you go and buy all the fancy cream with collagen on it, and you slap the... Listen, I've seen some face cream. I went to that, when was it? A couple weeks ago. I saw one face cream I sell on Amazon. The flipping face cream. I wanted to buy one for my mother for her birthday. 2 ounces of face cream was $100 US. Like, what the hell? I was talking about collagen and all of these things in there. Guess what? Your skin can't absorb collagen. So you can slap all the collagen you want on your face, it's not going anywhere. The collagen and vitamin E and all of these lovely things. And whatever, retinol, whatever, it is not going to reverse aging. The problem is not that you lack collagen in the blood or in your diet, that you lack it in the skin. Right? The cells that are there to make the collagen are dying off. There are fewer of them there. Right? If you have fewer fiber-producing cells, those cells cannot keep up with the collagen production. And because of that, even if you give them all the raw material in the world, there are fewer people to do the work. So the poor fibroblasts can't do a thing. So eat all the collagen you want, take all the vitamin E you want, unless you actually were insufficient in these things, it will not make one difference. Sorry to tell you. All right? So what do? Age gracefully, move on with your life. All right? There's a reason people age more visibly on their skins. And I'm going to be honest, particularly women. Have you ever noticed that women seem to age more quickly in the face than men? It's because once a woman hits menopause, the level of estrogen flatlines. Estrogen is one of the things that increases the production of collagen fibers, elastic fibers, right? As well as the fibroblast. So once you pass menopause, your production is going to diminish. That said, if you have a poor diet with low collagen and all these things, before you hit menopause, it means that your skin is already under stress. So when you hit menopause, your skin quickly starts to show signs of aging. Okay? So the better your diet is before you reach those ages, the longer your skin will look decent. Okay? But understand that the purpose of it showing up so quickly in a woman's skin And it's going to sound terrible to say it, so that men will avoid them. Why would I say such a horrible thing? Simple. What are males looking for? Males are looking for fertile females. If you pass menopause, you're not fertile, so what more you for? Right? And there, I can't remember the name of the comedian, but he always said, once a woman hits 40, she's effectively a man, which is why the world seems so much more terrible for her. Because she's no longer fertile and men don't care anymore. Hush. Such is life. Right? Now, obviously, as I said, there's really no way to reverse this. When they're doing all right, when they go and do the operations, what are they doing? They're not reversing the signs of aging. They're tightening the skin. They're cutting away excess skin and then stitching it back up. And because the skin looks tighter, the wrinkles go away. But if you've ever seen people who have had these plastic surgery, how their face looks unnatural, as far as I'm concerned, they don't look young. They just look weird, but what can I tell you, right? Also, remember with aging, Langerhans cells diminish. This is for everybody, right? So what happens? You're more likely to get damaged. You're more likely to get infections, right? Your skin gets drier because your sebaceous glands don't work as well. Even sweat production diminishes with age, right? Even your melanocytes produce less melanin over time. And these things show up clearly on your skin, especially the skin on your face. I mean, you can ask guys something. You can show up. You can take pictures of women from the neck down, and some of them the body looks absolutely great, like wow. And then you show them the pictures of the face, they're like, no, the face and the body don't match at all. Because once again, you're showing signs in your face to let everybody else in the tribe know whether or not you are A, fertile, and B, physically capable. Because in males as well, as the males get older, we're talking about from an evolutionary perspective now. Out in the wilderness, in the tribe, there's no cushy job somewhere. You have to fight to survive. A young woman, the worst thing she could do is talk about old man. Right? Because that male would not be able to provide for her when she's pregnant. So hopefully it makes sense to you that even if the physical body doesn't seem like there's a massive change, the face changes quite quickly. Why? To let other people know, say, hey, you can be friends with this girl, but she ain't gonna be she's not going to be giving you no children. Or in the opposite way, this man might give you a baby, but you're by your own. He's not gonna last. Right? Anyway, moving on. Cancer. What a lovely topic. Skin cancer is obviously, well, at least I assume it's obvious to you, not very common in darker skinned people. This is true. I have no problem saying that. However, a darker skinned person can get skin cancer. And when they do get skin cancer, it is normally worse on average than when a light skinned person gets skin cancer. Yes, you get it less often, but when you do, it's damn near always terrible. Okay? That's the first thing. So what is cancer? Uncontrolled cell replication due to damage to the DNA of the cell. Melanin is there to reduce UV damage to the DNA. So the darker your skin tends to be, the less UV damage your skin gets. Hence, the less cancer you should get. Right? Warts can be caused by various things. For warts, the most common thing to cause warts are actually viral infections. So a lot of viral diseases will cause, like herpes, for example, will cause warts. The warty tissue is a means of spreading the virus. The warty tissue is loaded with the virus. which is why, once again, like some of the herpes, when the warts start popping up, it means that they're highly infectious, right? Okay, so skin cancer, uncontrolled cell division, right? You got a mass of cells that just exponentially grow, forms a tumor. Tumor gets big enough to cause damage to the surrounding organs that kills you, right? Now, tumors can be benign or malignant. How can a tumor be benign? Some tumors will grow to a certain size, big enough to be obvious, but not big enough to significantly damage the organ and then stop growing. And hence, it is benign. Many people are walking around with benign tumors, right? It's there, but it's not really doing anything much. Malignant means it continues to grow until it starts to cause damage, okay? Now, it says benign cat growths are not necessarily cancerous, okay? And they're rarely life-threatening. Now, the reason I say not necessarily cancerous is because there have been cases where benign growths have become cancerous. But usually, let's say you have a weird lump somewhere and you've been checking the lump and it hasn't really changed size in 6 months to a year, it's probably benign. It's probably no big deal, right? And generally speaking, you can just cut them out to move on with your life. And they won't grow back, right? Now, with a malignant cancer now, because the cells of the tumor are happily replicating, they want to make more and more of themselves. What you can have happening is that the tumor itself can be fragile, as in this big lump of cells are not tightly packed together, not tightly held together, and bits and pieces of this tumor can actually break off and get into your blood, right? And that is the worst thing that can happen. If you have bits and pieces of tumor floating around in your blood, they can set up shop in other places in your body. So you can imagine you have that skin cancer with capillaries near the tumor. Then cells from the cancer break off and go into the capillary. And from there, they spread to your liver, to your kidneys, to your brain. And all of a sudden, you go from having skin cancer to having cancer all about. And of course, that kills you, right? When this happens, we say the cancer has metastasized. All right, that is metastasis of the cancer. So I can say to you, guess what? Skin cancer by itself is probably not going to kill you. But when it metastasizes and spreads, that is what is going to kill you. I mean, everybody has famously heard that Bob Marley died from skin cancer. Bob Marley did not die from skin cancer. Bob Marley had skin cancer, which he did not treat. And then that skin cancer metastasized. It spread from his toe. I think it was the big toe, them say. If I remember the story correctly, they found out that he had a he was treating his cancer with weed, of course, because they always do. And the tumor had grown to the point, where it was affecting his ability to function. So he then went to the doctor, and the doctor's like, hey, your big toe has a giant tumor in there. We need to cut it out. And he's like, no, Rasta can't go even with a 9 toe. Or some nonsense. So he decided to treat it instead of having it removed. And of course, it metastasized. The cancer spread from the toe into the blood, into his lungs, and from what I understand, that's what finally killed him, right? But guess what? He died with all his toes. I mean, so that's something, right? All right. That said, 2 most common types of cancer. You have basal cell cancer and you have squamous cell cancer, all right? Now, they're usually found on the head, face, neck, and arms. Why? Because those are the parts of your body that are most exposed to the sun. That said, you can get skin cancer anywhere. Remember, I just said to you, Bob Marley got it in between, well, on his big toe, right? Yeah, Bob Marley really was going on, but think half of Europe must have be related to Bob Marley. And they love a white woman too, you see, man. Anyway, moving on. Now, basal skin cancer, as it says, grows slowly, and it is usually occurs on areas of the skin that, of course, have been exposed to sun. It's the most common on the face, but they rarely spread to other parts of the body, right? Now, I remember this story a couple of years ago where this fellow in the US, this is the US, right? He developed a basal skin cancer, okay? He developed a patch of skin cancer, and I think it was his forearm. So he went to the doctor and said, boy, doctor says, yep, that's a cancerous growth. We need to have it removed. The guy's like, okay, no problem. And he asked the doctor, so how much is it going to cost him? This guy was just a regular guy, woodworker by trade. He didn't have any insurance. I said, okay, the operation is going to be 15,000 US dollar. 15,000 US dollars is well over $2 million. And I was like, hell no, I'm not paying that. So my guy went home, took out his belt sander, put his arm on the table, and he literally sanded right down until he saw blood. He sanded off the cancer. Healed, he was cancer-free. I am not suggesting this is a good idea. I'm just telling you what he did, right? But remember, that was a basal cancer. So he didn't have to worry about it potentially have spread the lymph nodes and to the blood, etc. Squamous cancer is different. This one can break into pieces. This one can spread. This one can end up in your lymph nodes and other places, right? So you couldn't just sand off it and move on with life, right? So basal cancer is not as bad as squamous. Because remember, metastasizing is the important part here, right? Okay, so what determines your risk for cancer? Obviously, UV. At the end of the day, most of these skin cancers are caused by UV radiation. Once again, if you're a darker skin person, this is not as important, right? But if you're lighter skin, the more exposure to the sun you have, the greater your chance of developing melanoma, which of course is a cancer of the melanocytes, right? Now, understand also that because UV radiation does constant damage, if you're a lighter skin persuasion, it also damages your fibroblasts as well. So what you find that means that women who are of a lighter skin that spend a lot of time in the sun, their faces age more quickly, right? So if you're light skin in Jamaica, you should try and stay out of the sun because it will age you. Think about it. You have a light skin girl, you have a dark skin girl. You know, Jamaica, you have this preference for browning. Fair enough. You know, when you're in your 20s, that's fine. Check by the browning them by the time they're 35, 40 and compare them. The brownie look like she's 50. And the dark skin girl looks like she's still in her 20s, maybe early 30s. In terms of their skin. Because of the damage due to UV radiation, right? So if you're light skin and in Jamaica, invest in a bottle of sunscreen. Right, black don't crack. That there's actually something to that. Right? Less UV damage, less loss of fibroblasts means your skin ages more slowly if your skin is darker. Right? I've seen people in Jamaica in their 60s with not one wrinkle on their face. And I've seen women in their 30s a full up. Right? All right. Moles. The more moles you have on your skin, the greater the chances are that you will get skin cancer. Right? So if you have lots of moles on your skin, you have to be particularly careful. It increases your risk of cancer, especially if you have big moles, right? We already mentioned the skin business, right? Fair skin, dark skin, we know. I should also mention that also there are two types of melanin, okay? You have normal melanin, and if you have normal melanin, of course, you tend to have, even if you're a white person, let's say you have normal melanin. This is how you get like dark black hair, brown hair, black eyes, brown eyes, these kind of things, right? That's normal melanin. If you have the second type of melanin, this is the type of melanin that doesn't work very well. This is the type of melanin you normally find in people of Scottish descent. So these are very, very pale-skinned people. And when you put them in the sun, they tend not to tan, they tend to burn. Because that type of melanin doesn't work very well. And because it's not very good, that's how they get red hair and like green eyes and blue eyes and, well, these lighter color eyes, right? So and by the way, black people can also have the second type of melanin. So their skin is still going to be dark, you know. But even with the darker skin, because of the second type of melanin, you see a darker skinned person with freckles. I used to say that doesn't make no sense. What am I doing with freckles? Right? Because they're descended. Remember, we had a lot of people from Ireland come to Jamaica in 1800s. So some of you in here are actually descended from Irish. Right? And because you're descended from the Irish people, you might actually have this second type of melanin, which means that when you go out in the sun, you want somebody else of the same color, your skin has stripped and they're perfectly fine. You know, so your melanin is not that hot. It also means that you need to be more careful than that other person. You need, once again, to invest in a bottle of sunscreen, right? And yes, I'm aware of the fact that a bottle of sunscreen in Jamaica is like $4,000. But it's cheaper than skin cancer. Right. 10% of people with melanoma, skin cancer, have relatives that have skin cancer, which means it's genetic. I paid $4 something for a bottle on Amazon. People who are taking immunosuppressant and drugs, they are also more prone to skin cancer because when a cell becomes cancerous, your immune system normally kills it, right? So if you're suppressing your immune system, the cells that become cancerous are more likely to get away, right? Age, older you get, the less melanin you make, the worse your Langerhans cells act, and the fewer of them you have, so increased risk. Now this here, xeroderma pigmentosum. This is one of the rarest forms of one of the rarest skin conditions in the world. Okay? Hear how this sounds. In ZP, or XP, I should say, people cannot repair UV damage to their skin. When somebody with XP goes out in the sun and the UV radiation hits their cells, it just kills the cells. They'll be exposed to the sun for 10 minutes and the skin start peeling and turning red. It's crazy, right? Extreme damage. Now, a lot of people believe that people with XP are where we get myths of vampires from, right? Because this is something that occurs a lot in white people, obviously. So you places like Romania and those places, the vampire myths. So these people couldn't go out during the day. They always look pale. When they get exposed to the sun, they get extreme sunburn. So when they put all that together, that sounds like a vampire, right? That does sound like a vampire. If you can only go out at night, you're roaming the place in the dark, you look suspicious, right? Now, a person who has already had skin cancer is also more likely to get skin cancer, right? Prevention, sunscreen, obviously. And remember, if you're a darker skinned person, you're far less likely to get skin cancer. But if you're a lighter skinned person, limit the amount of time you spend in direct sunlight, right? Now, let's talk about skin cancer and then we'll take our break. In terms of recognizing skin cancer, we have something called the ABCDs of skin cancer, right? when you're trying to diagnose skin cancer, this is what you use. You look at the shape of the cancer so this is looking at the moles on your skin now. You have asymmetry, border irregularity, color, and diameter. Right? The idea is that the more asymmetrical the blotches on your skin are, so they're not round or oval, the more likely it is to be cancerous. The more irregular the borders are, as in they can say they look patchy, the more likely you are to have skin cancer. And if the color of the skin pigmented the area seems to vary, there's a lighter patch here, a little darker here, very dark up here. So the color is varying. That's also a bad sign. And for the most part, diameter, if it's bigger than a 1/4 inch, if it's bigger than the head of a pencil, the pencil eraser is more likely to be cancerous, right? So here we have a normal mole. So normal moles tend to be oval to round, right? Here is a melanoma. You can see this is definitely neither one, right? Look at this. You can see here, nice oval, continuous, consistent border. This border is all over the place, right? Color. Here's a normal mole, one nice consistent color. This one here, so dark patches and light patches. That's a bad sign. Once again, diameter, moles should be able to take a pencil and the head and the eraser should cover it up. If not, that's a bad sign too, right? So now you should be able to diagnose any kind of weird patches you see on your skin. Now, I want to mention UV damage. This, of course, is once again, this is for the lighter skinned amongst us more than the darker ones. When you get exposed to UV radiation, this person is under this is what in infrared light. So they're looking basically under the person's skin. You see all of these patches you're seeing here. If you look at the old lady here, so her skin doesn't look anywhere near so spotty. What you're seeing here is all of these here, this is damage that has already been done that will eventually show up on her skin. It hasn't showed up yet, but as she gets older, her skin gets more and more patchy because this is previous damage. So this done gone bad already. So this young lady here, all of these spots you're seeing here, she's not seeing them on her skin yet. But as she gets older, they're going to show up. So if you're a younger person who's light skin, you might not see the damage yet. But as you get older, the damage is already there. So they start showing up. Right? So might say, oh, my skin is nice and clear now. Check me in 5 years. Right? So once again, if you have a lighter skin persuasion, seriously consider investing in a bottle of sunscreen. If it's only for your face and your hands. Right? All right, last thing here now, we're going to talk about our burns. Right? We're going to talk about the degrees of burns and what they mean. Okay? Now, obviously, a burn, when we say burn, we're not talking about fire necessarily. You can get burnt. Anybody ever stick their hand in the hot water by accident? Or take up a hot cup, right? Hot water burn. Different from a sunburn, right? Radiation burn. It's not a reason you worry about very much, right? Somebody mentioned oil burn, absolutely, right? As somebody who's been electrocuted over a dozen times, and burnt by it, electrical burns, right? Or acid. Ever get acid splash on you? I have. Wasn't fun, right? And base does the same thing. Basically, what is happening here is that in all cases, you're drawing moisture out of the cells and you're killing them. Actually, I acid myself, so I can't say anything to anybody. I was working on a car battery and I was emptying the car battery. I wasn't paying attention to what I was doing and I got splashed. And of course, it splashed from my foot. But of course, I was holding a 75-pound battery at the time, so I couldn't just drop it. Anyway, such is life, right? Now, let's talk about the degrees of burns, right? We have first degree. Nicest, but well, I mean, Nice burn seems like a contradiction, but it's the least bad of the burns, okay? Normally, a first degree burn is only epidermis deep. You're only damaging the upper layers. So you might get a little redness, a little swelling, a little, might hurt a bit like a sunburn, all right? That's all. Normally, a day or two it goes, no big deal. Second degree burn, this is normally now in the dermis, and you tend to develop blisters with this one, okay? And you tend also to lose hairs in the area. So you develop a blister, the hairs fall out, and it can damage your sweat glands and things. But given enough time, days to a couple of weeks, your skin will go back mostly to normal, right? Third degree burns now can burn straight through the dermis, and they can permanently destroy hair, sebaceous glands. It can go down into the hypodermis and destroy fat layers. These are the worst burns you can get. These burns are permanently disfiguring burns, right? Now, generally speaking, when you get burns like this, you first need to, weirdly enough, it sounds strange, but when you get somebody coming into the hospital with a severe burn, you need to give them IV fluid. Because remember, the burn is going to pull water out of their body. So you need to, and debridement, you need to clean the wounds, right? And you need to give them nutrients. Yes, Zanel?
Sir, is that like when you have like say iron burn your heart at home, they normally put your hand on the running water?
No, that would be a second degree burn. I mean, what I'm talking about is like I know there's a case in a children's home I'm associated with where this mother decided to teach her daughter a lesson. And when the daughter is asleep, she go into the bedroom and take a hot iron and put on the daughter back. And it burned straight through, and she now has a permanent mark on her back. You can see the iron, the shape of the iron, and the holes and everything there. That's what I mean when I say third degree burn. But if you just touch the iron, you get a blister, you move on with your life. That's not so bad. As I said, third degree is permanent debilitating damage. Listen to me now. Some of those people those children in those children homes, some of the things them suffer, I can't even describe it. Right? Or I mean, then again, I know this case of this woman who thought her man was cheating on her, and she got through him phone and find something she never liked. She went and she boiled a pot of hot water, and she in her bed asleep, and she just showed hot water on him. Right? And there was this other case, this was in Jamaica a few years ago, when my girl was very vexed, and she and the man, apparently, according to her, the man must have slapped her. Can't say. But she was boiling a pot of porridge, and she go in the kitchen and with a pot of porridge and pour it over the man's head while he was watching TV. So, yeah. And trying to porridge burn far worse than water burn. Right? Anyway, we want to finish this. So, first degree burn, epidermis alone, no big deal. You'll heal, no problem. Second degree burn can burn down in the dermis and damage structures in the dermis, but usually it's not deep enough to cause severe damage. Third degree burn, it burns straight through the dermis and causes permanent damage, right? And those are the ones that can kill you. If you get more than 20% of your body in a third degree burn, you can go into shock and die from it. All right? All right, so we stop here. As I said, I want to start the endocrine system, right? So can you guys come back at 4:50 and let us just do like 45 minutes and then I'll let you go, okay? I just want to start, so I want to make sure we can finish it on time. Right? Because, yeah, go ahead, Tessinic.
Sir, for the skin and the skin color, I'm gonna hear talk about vitiligo.
Vitiligo is basically when the skin loses color in patches. So melanocytes stop working in patches on the skin. It's also a genetic disorder. Over
Sir,
time,
is that in the case, what you call it? Vertigo, something like that. When they
vitiligo is what
lose, yeah, when they
vitiligo.
lose pigment.
That's what she's talking about. So in vitiligo, it is also genetic, but it's a progressive disorder in which as they get older, the melanocytes become less and less active. So you start getting patches of white skin, if you want to call it white, and it can start spreading over time. Right? But normally somebody with vitiligo looks fairly normal when they're a child and gets progressively worse as they get older. According to Michael Jackson, that's what he had. Yeah, nobody believes that. But you know, whatever.
Sir, I heard that like when the person lose all their pigment in their skin, they can get back that pigment.
Normally you lose pigment in your skin because your melanocytes stop functioning. You can't get that back. That said, if you do have functional melanocytes, okay, you can actually take a hormone treatment to darken your skin. All right, I remember, so if you want your skin to be darker, you can actually get a prescription that causes, and when you take the hormones, it increases melanocyte activity, your skin gets dark over a period of a few weeks to months. So, but remember, you have to have functional melanocytes to begin with for that to work, right? So, for example, if you're an albino, taking the street wouldn't do a thing for you. All right. So remember, let's take 20 minutes. Come back at around 4:50 so that we can start the endocrine system, right? Or do you want to just go longer on Friday? What do you prefer?
Sir, the break.
All right, so we'll take the break and come back in 20 minutes. For those who want to speak to me, let's talk to me when we come back here. Because this can't run too long or else it won't be able to upload. So I need to stop now so we can upload this one. All right, folks, speak to you all in 20 minutes.